Okay, so I want to do number 58b from the Calc Chapter 3 packet. So in this one, let's see, we've got y equals 3x plus x tan x, and we need to find dy dx and then check it on our calculator. So actually, let me see if this, here we go. Here's the calculator. No, let's not do that right now. Okay, so I'm going to minimize that for now, and then we'll bring that back when we need to check it. So dy dx, let's see, y equal, I'm just going to rewrite this, 3x plus x tan x. And we need dy dx. So that's basically the same exact thing as y prime of x, or just y prime. So 3x turns into 3. And then this, when I take the derivative of that, I need to use the product rule because it's x times tan x. So let me call x my u and tan x my v. And then this here is going to be, I'm going to write it below, u v prime plus v u prime using the product rule there. So that's going to turn into x, and then v prime, the derivative of tan x, excuse me, derivative of tan x is secant squared x. That's one that you should have memorized. Plus tan x, that's v, times u prime, which is 1. Okay, excuse me. So this turns into 3 plus x secant squared x plus tan x. That's our final answer. So what we want to do is we want to check this on the calculator. So what I'm going to do is go to, well actually first let me make sure I'm in radian mode. Okay, that's good. And then for y1, I'm going to type in, let's see, 3x plus x tan x, like that. For y2, I'll type in the derivative that I found, which is 3 plus x, and then secant squared I'll type in as 1 over cos x squared. So I'm squaring the 1 over cos x. And then I need to do plus tan x. So if I just graph y2, I'm not going to know if that's the derivative or not just by staring at it. Let me turn off y1 here. But what I can do is I can graph the derivative of y1 on the calculator where it can try that. So I'm going to go to math. Oh, come on now. Math. And then go way down here to n-deriv. And now it's asking me what do I want to take the derivative of. So I want the derivative of, really, it should have you fill in that box first, but the variable's x. The function that I want to take the derivative of is y1, and you can do a shortcut to get to y1 by alpha f4 and hit y1, or if you have an older calculator you would go to variables, y variables, function, y1. And now it would say, okay, you want to figure out the derivative of y1 when x is what? So if I want to pick a specific value to figure it out, then I'd say like 8. But I really want it to figure it out for all my x's. So I'm going to type that instead. And let me scroll over here and make that one thick. So I'm going to graph just y2 and y3. That's it. Notice I turned off the equal sign here for y1. So if I graph, there's my graph of the derivative. That's the 3 plus x secant squared x plus tan x. And then I'm hoping that the next one's going to look exactly the same, and that's the thick one, which is just the calculator's y prime. And sure enough, it looks pretty much exactly the same because it's covering up the first graph. So, okay, hope that helps, and that shows you how to use the calculator on these things too to check. Okay.